Funky smell in the midnight air. A woman crying 'cause her child got lost somewhere.
Hello and welcome to the practice problems video for the section on inverse trig functions. Okay, number 1 asks us to evaluate the following expressions, giving the answer in radians. Okay, so let's work with the first one, inverse sine of -1/2. Okay, so this question is asking, so what angle can I plug into the sine function to get -1/2? Alright, so if we look at our unit circle, -1/2 is around here or so we could get this angle here or this angle here. This angle would be 7 pi over 6, and this angle is 11 pi over 6. And if we consider the range, or the domain that we're allowed to use for our angles, it's from -pi/2 to pi/2. So that'd be from here to here, okay? So this angle over here, the 7 pi over 6, that's definitely not in it. But this 11 pi over 6 is technically not in this interval, but what we could do is subtract off. So we're going to take our 11 pi over 6. We're going to subtract 2 pi, which we can write as 12 pi over 6, okay? And to get a negative pi over 6, which is definitely within this interval here, okay? So our answer is going to be a negative pi over 6 for this first, like, part A, okay? Part B, which I just labeled, is cosine inverse, or inverse cosine, of negative radical 2/2. So again, let's look at our unit circle here, okay? So negative radical 2/2 for cosine is going to be, okay, so what angle makes this right there? Okay, so that's either going to be 3 pi over 4 or 5 pi over 4 in order to get a negative x value there for our cosine. And if we keep in mind that our domain was 0 to pi, so that means from here to here, then we see that 5 pi over 4 kind of just falls off the boat, but 3 pi over 4 makes it. So our answer is going to be, for this one, this is equal to a 3 pi over 4. Okay? Alrighty, now for the last one, part C, we're going to have inverse tangent of negative radical 3. Okay? So let's look on our unit circle here. And that's kind of harder to see because it's like, wait, tangent isn't x or y, it's y over x. So maybe the unit circle isn't the best way to go. But let's keep in mind definitely the domain that we want to consider, which is negative pi over 2 up to pi over 2, non-inclusive. Okay, so not including those endpoints. What we can do is say, okay, well, we're looking for an angle, tangent theta. So we're looking for some angle theta, so that tangent theta, which is equal to sine theta over cosine theta, so that this is equal to negative radical 3. Okay, so what we can do with this negative radical 3 is say, okay, so we have this sine theta over cosine theta. Let's rewrite this negative radical 3 as being over 2 and then multiplied times 2 over 1. So this might seem a little spontaneous, and it is a bit, but knowing our knowledge of the unit circle, we know that there are a lot of like radical 3/2s and 1/2s and stuff, so we can actually move this guy below by kind of saying like we're dividing by a fraction, okay? So what we have on top is still this thing, this negative radical 3/2, but on the bottom we're kind of like dividing by 1/2, okay? So what we're really looking for is some theta, so that sine is equal to this thing, and that cosine is equal to this thing on the bottom, okay? So where are we going to find a sine, or where are we going to find an angle that gives us a negative sign like that? So that'd be almost like down here, right? And then cosine is positive. So that makes sense. Y is negative, cosine, or x is positive here. Alrighty, and this is actually the angle. We want it to be in between this interval. So we can't really say that this is 5 pi over 3 because that doesn't fit into our interval. But we can subtract, kind of subtract by 2 pi, so go around the circle in the opposite direction, and we'll get a value of negative pi over 3, which is definitely within our interval. Okay?